What's up guys, and welcome to another video about Jetpack Compose and Canvas. In this video we are gonna build such an interactive calendar where we can click on different days and we will see the corresponding list we have to do on this day. In my case I've just added always the same. You can see the days just changing, and if we have a closer look then you can see we have also a cool animation here which starts at the point where we click and then it expands until it reaches the specific day border, like you can see here. Alright, okay, I'm in an empty Jetpack Compose project. I've just removed the default created stuff from Android Studio, and also I've added some colors, but I think we only need these 3 colors. You can find them in my GitHub's repository, which is linked down below, or you simply use your own ones. Okay, let's straight start with the calendar composable. For that we will have a private const val calendar rows, which is equal to 5, and we will also have a const val for the calendar columns, which is equal to 7. You can also choose different values. We will make the calendar looking depending on this calendar rows and calendar columns, and then you can decide if you want to show like 7 columns and 5 rows or some different rows and columns count. Then we will have a composable function, which will be our calendar. It takes a modifier, which will be the default modifier here. Then we have a calendar input of type list of type calendar input. And we first need to create this calendar input, so we can go down here and create a data class. Normally I would put this in some kind of state or data folder package, but for this tutorial this is fine. This calendar input will have a value day of type int and a value to-dos of type list of type string, and we can set this to an empty list by default. Up here in our calendar composable we can then also define an onDayClick lambda function, which provides an integer later. So this will indicate on which day we actually clicked and will return nothing. Then we also have a stroke width, so the width of the different calendar bars. We will set this to 15F by default. If you want to make this calendar a little bit more smaller regarding these different lines, then you can also adjust this value. And we will also pass a month here so that you can reuse this calendar for different months. In this case, in this tutorial, we will just use September, but you can also implement some kind of logic with left and right arrows to switch between different months. And then you can pass the current month which you want to show. Down here in this calendar composable, we can then define a column, and this column will have a text, and the text will be our month. The font weight for the month will be semi-bold. The color will be white, and also the font size will be set to 40 SP. And for the column as modifier, we will pass the past modifier from above, and the vertical arrangement will be arrangement.space by 10 dp. Below our text, we can then invoke our canvas. The modifier will be modifier.fillMaxSize, so the canvas will expand to the whole width, and it will be as height as this modifier here is minus the height of this text composable. Then we can open the draw scope, and first we need the canvas height for calculations later. The size dot height will give us the canvas height. Then we will have the canvas width, which we will get from size dot width, and we also can define X steps and Y steps. So the different steps between the different days, because they are depending on the canvas height and our calendar rows and the canvas width and our calendar columns. We can say, well, Y steps is equal to canvas height divided by our calendar rows. Then well, X steps is equal to canvas width divided by the calendar columns. After that, we can draw a big rounded rect, which is around our calendar grid. So draw round rect. For the color, we will pass orange. For the corner radius, we will pass the corner radius with 25F and 25F for X and Y. And for the style, we will pass a stroke And the strokes width will be our stroke width, which we will get from this here. When I work with Canvas, I always like to start the app as soon as possible so that we can always see what's currently drawn on the screen. And we will also do this here. So let's go up to our main activity and I will copy and paste the function here, which creates our calendar items. I don't think I should type this off here. And I also think we should make this a little bit smaller here, like this. Yeah, I think you can still read this very well. And what this function does is it just creates a calendar list. It hovers over 31 items here, and for each item, we will create this calendar input as I already showed in the introduction. We will always have the same to-dos, and just the day here changes. And down here, it returns our calendar input list. Then we can go up to our set content here. We will have a box which takes a modifier. This modifier will fill the max size and will set the background to gray. The box content alignment will be alignment.top-center. Then we can open the box scope and in here we will invoke our calendar. So like this, let's put this in separate lines. For the calendar input, we will create a state val. So val calendar input list by remember mutable state of create calendar list. So this is our private function, which is down here. This will create our calendar list. Then we can pass this here, calendar input list. We will leave the click logic empty for now, because we will first draw the calendar and after that we will go for click events. And for the month, I will simply pass September here. And of course, if you would like to make this a year calendar where the user can switch between different months, then you would need to apply some different state and data logic here. But this tutorial will mainly focus on drawing the calendar and detecting the clicks on the different days. And yeah, but with some little adjustment, you can also make this a real calendar, which is also clickable regarding switching different months and all that stuff. For the modifier, we will pass a modifier .padding 10dp and fill max width. The aspect ratio will be 1.3f, so the calendar's width is 30% bigger than its actually height. Then we can start this and have a look at our rounded rect, and I think this looks good so far. Now let's draw our grid. For that we can use for loops. The first for loop will be from 1 until our calendar rows. So this will be the lines from the left to the right, and we only need 4 lines here because we have 5 rows. So we will exclude calendar rows here, which is 5, and start from 1. Then we will say draw line. The color will be orange. The start offset, where the draw line should actually start, will be offset 0f, and our y steps multiplied with I. So we will start drawing at x is equal to 0, which is the left side of the canvas, and our y steps, which indicate the different steps from the top to the bottom, multiplied with I. And if I is 1, then we will draw the first line, for example, and if I is 2, then we will draw the second line. But this is just the start offset. We also need an end offset, which will be offset, and you can pause this video and think about which is our x offset here. It's the canvas width, because we draw from the left to the right, and the very right is the canvas width. And of course we also have the y steps multiplied with I here. And then we have also a stroke width, which will be our stroke width, which we will get passed from above. Then we can start this and you will see what this does here. You can see now these are the horizontal lines here. We can copy and paste this for loop here for our calendar rows and do some little adjustments. We will say calendar columns here. The color will be still orange, and now we need to change a little bit here. Here we need our x steps multiplied with I as well. And for the columns, we will always start at the top. So the y value will be 0f. And then we can here say x steps minus I as well, because our x value does not change from the start to the end because we draw from the top to the bottom. And for the y value, you can pause again now. It should be clear, I think. The canvas height, of course. And the rest remains the same. Then we can start this again. And now you can see we have a nice grid here. We could also make this a nested for loop and only draw in here inside the inner loop. And we could draw rectangles here for each day, one rectangle. But I think these two for loops which run after each other is a little bit more easy to understand. And also, if we would use the rectangle approach, then they would be always overdraw some sections of rectangles which are around this rectangle. Now we will draw the different day numbers which are in each rectangle here in our grid at the top left. For that we first need the text height, which is equal to 17 dp.2pixel. This is just a value I experimented with. You can also use another text size. But we need this text high here for applying an offset that they don't get drawn over the grids actually. Now we will enter a for loop again for I in calendar input dot indices. So we go over each item here in this calendar input and they are also our days. So for each day we will enter this for loop. In here we need the text positioner x, which is equal to x steps multiplied with I modulo calendar columns plus our stroke width. I will explain this after we define the text position y as well. So text position y is equal to I divided by our calendar column multiplied with y steps plus the text height plus the stroke width divided by 2. Okay, what does this mean? We have our text position x, which is the position of the text drawing on the x-axis, the horizontal axis. Then we have the text position y, which is the vertical axis, so from the top to the bottom. Then for the text position x, for example, we have the x steps, so each step for each day. So from the left, one step to the right and so on. And we multiply this with I modulo our calendar columns. I hope you know what this modulo does. If not, you obviously need to check this out. And I will go from 0 to 30, for example, if we have 31 days. And this modulo always returns just values from 0 to our calendar columns minus 1. So this result in the parentheses here will be always from 0, 1, 2, 3, 4, 5, 6, and then again 0, 4, 5, 1, 2, 3, 4, 5, 6. And so we always multiply this x steps just with a value from 0 to 6. So we will go over our x-axis in the right way. And this stroke width is just a little extra offset here so that the value does not get drawn on the grid. And for this text position y, we can't use the modulo operator because we first want to draw all the values on the horizontal line. And this result here should only increase by 1 if we go to the next line in a vertical way. So if this I here is 7 and the calendar columns are also 7, then this will be 1 the first time. And this is also right because if I is 7, we are on day 8 and we are in the next line then. We will multiply this, of course, with our y steps because this is the step size. We go from the top to the bottom and we apply this little offset, our text height, and the stroke width divided by 2 because we don't want to draw the text at the grid lines. And we also need to add the text height here because the text starts drawing at the bottom and then it gets drawn to the top. Alright, okay, this was it for the complex part of drawing these different numbers. Now we can say draw context.canvas.nativecanvas.apply and we can then draw the text. Draw text. For the text we will simply pass I plus 1 because we are always 1 day above our current iteration I because I starts with 0. Then we will pass the text position x, the text position y, and also we will apply a paint here. Paint.apply, the text size, will be our text height, and the color will be white.toRGB, and we will also make this bold. So we will set this to true, and then we can launch the application and have a look at it to see if everything worked, and I think this looks great. Alright, okay, this was it for drawing the calendar. Now we will have a look and implement the logic for our animation and clicks and the click processing. So let's go above to our canvas. And first of all, we need some state vars. We need the canvas size as the state var because we later need to access it inside the canvas modifier, and there we don't have access to this size.height and width, so we need to make this a state var here, which starts with mutable state of offset.0. Down here we can then set the state var to canvas size is equal to offset, canvas width, and canvas height, like this. Then we need additional state vars. We need a var click animation offset, so where the user actually clicked. This will be by default offset.0 as well. And we need a var animation radius. This will be the radius we will animate later. So when the user clicks on a specific day, then the radius of a circle will be expanded until it gets clipped off of the border of the specific day item. This will be mutable state of and 0 by default. The last thing we need is a coroutine scope to launch our animation later, and we can get the scope from, remember, coroutine scope, so that it is also scoped to the composable's lifetime. Now here, where the canvas modifier is, we can say pointer input and pass true here, and then we can detect tap gestures. And we will need the onTap method, which will provide an offset for us. So this offset is the exact position where the user actually tapped. The concept here is really easy to get a day. We will just need to calculate the column and the row, and then we get the corresponding day with an additional little calculation. But we need to consider some things when we calculate this column and row. We will say var column is equal to offset.x divided by our canvas size.width. And why don't we have access here? Oh, okay, I think I know what this means. And we need the canvas width here, but we define this as an offset here. This needs to be, of course, size.0 because we also want to save the canvas size here. And in here, where we actually initialize it, we also need to change this to size. And then we have access to the canvas size.width. And we need to multiply this with the calendar columns and map this to an integer and say +1. For the row, we can simply copy and paste this here and rename this to row. The offset will be this time offset.y, the canvas size.height, and we take the calendar rows here with the same principle to calculate the row. So how does this work? This will calculate the relative amount of the user click on the x-axis. This value can go from 0 to 1.0. And we multiply this then with our calendar columns so that we get the corresponding click on the column. Then this toInteger will cut off the commas, but even if we have something like 5.99, then this will cut off the 99s, and this is why we use this +1 after that. And the same principle for this row calculation. But of course, this time for the offset.y, the canvas size.height, and the calendar rows, because we are now talking about the vertical relative amount of the user click. And again, this +1 is also applied because if we are in the first column or row, then this calculation will result in 0. And so, like in a for loop, we start with 0 to calendar rows -1 or to calendar columns -1. And to get the right column and row, if we want this from 1 to 7, for example, or 1 to 5, when we have a look at the rows, we need to make this +1. Now we can calculate the day, which we will get from a column plus row -1 multiplied with our calendar columns. Okay, to understand this, we could just make a little example here. Let's assume the user clicked on the second column and on the first row. Then this column would be 2 and this row would be 1. This would result in 0 multiplied with the calendar columns, does not take any effect, so we would have day 2. Then let's take another example. If we would click on the first column and the second row, then this would be 1. The row would be 2 minus 1 would be 1 multiplied with 7. This would result in day number 8 because the second row and the first column is day number 8. Okay, all right, I hope this got clear. Then we can say if day is less or equal than our calendar input.size. So if the day the user actually clicked was really on the calendar, because if we have a look at the application, then on the right at the bottom there are 4 empty grid items here, and we don't want to detect tap gestures if the user clicks on them. So this is what this if condition here is about. And then we can invoke on day click and pass the day. And we will say the click animation offset is equal to offset. After that, we can use our scope.launch to get a coroutine scope where we can start the animation. Animate 0f to 225f. This will be the target value, how big the click event actually should be. I will talk about this value later. And the animation spec will be tween 300, for example. And then we can open this, and I hope you can see this. We get the value here, and the second parameter isn't needed. And in here, we can then say animation radius is equal to value. This animation radius is our value, our state var, which we defined above. And we can pass this now inside another draw element in our canvas to make this animation actually triggering. All right, okay, I was quickly at the hairdresser, and now we can finish this off. We can copy this row and column formula and paste it down here, because we also need to access the column and row for our animation in our draw scope. But for the offset, we will say click animation offset.x and here click animation offset.y. And then we need to define a path, because we need to clip this animation to a specific path so that this animation does not exceed the grid item of our clicked day. And this path will be exactly the grid item. So we will say val path is equal to path.apply. In here, we will now define the path of our grid item, so a rectangle path. And we first need to move the cursor to a specific point where we want to start drawing. This will be column -1 multiplied with the x steps. And for the y value, we will say row -1 multiplied with the y steps. So this will be the top left of our grid item. After that, we can draw our first line, which goes from the top left to the top right. This is why we say column without the -1 multiplied with the x steps. And for the y value, we still have row -1 multiplied with the y steps. So this will draw a line from the top left to the top right of our grid item. The next line will be a column multiplied with x steps as well, but now we will go from the top to the bottom. So we will say row multiplied with y steps. And then we are at the bottom right. The next line will go from the bottom right to the bottom left. So we will say this time column -1 multiplied with x steps, and here row multiplied with y steps as well. After that, we can close the path for the last line. We don't need to define the drawing for the last line. We can simply say close. And then we have our path of the grid item. We can apply a clip path function now and pass our defined path. And everything that gets drawn inside this draw scope will be clipped to this specific path, so it won't exceed the path's borders. In here, we can then draw a circle. This circle will have a brush, and this brush will be a radial gradient. For the colors, we will pass a list of colors. This will be orange.copy 0.8f, so that we have a little bit of a transparent here. And the second color will be orange.copy 0.2f, so even more transparency here. And the center will be our click animation offset. So the exact point where the user actually clicked. So if he clicks in a grid item at the bottom, then the animation starts from the bottom and expands and fills the whole half here. The radius will be animation radius plus 0.1 f. Because this animation radius is 0 by default and our app would crash if we pass 0 for the radius here. So we add this little floating value. And this is for the brush drawing. This is not the draw circle. This is just that the brush, our radial gradient, looks like the user really clicked on this position. So the gradient starts from there. And then we also need, of course, the circle drawing. And this is the same principle here. We have our animation radius plus 0.1 f for the radius. And for the offset, no, for the center, we pass the click animation offset. All right, okay, this was actually it for the canvas drawing. Let's go to our main activity and make the click item also take effect on the UI so that we get the list of the different to-do items when we click on a specific calendar element. We will say, well, clicked calendar element by remember, mutable state of, and we need to define a type here. This will be of type calendar input, but it's optional because by default there's no clicked item and the default value will be null. This onDayClick lambda function will provide us the day the user actually clicked. We can name this today and set our clicked element of the calendar. Clicked calendar element is equal to calendar input list dot first. And this first will just return the first element which matches the given predicate. So it.day is equal to day. Below our calendar composable, we will define a column, takes a modifier which fills the max width. The padding will be 10 dp and the alignment will be alignment.center. In here we will just list all the to-do items of our clicked calendar element. In your projects you should maybe apply a better UI, but this is just to show you that we get access to this clicked item and that we can list the different to-do items. We can say clicked calendar element to-dos dot for each. This needs to be an optional chaining because this clicked calendar element is null by default and it shouldn't show a text if the user did not click on a calendar item yet. For the text, we can say if it.contains day, it should just show it, and else we want to apply a little line before the text so that we can list up the different to-do items. For the color, we will pass white, the font weight will be semi-bold, and the font size will also depend on if it's currently the day or a to-do list item. If it.contains day again, then we will set this to 25 sp and otherwise to 18 sp. Now we can try this out. I have enabled my mouse so that you can see where I'm clicking. I will click on 17, 16, 23, and I think this works very well. Let's also zoom in a little bit so that we can see that the animation start and the gradient start actually goes from our mouse click. If I click on 17 at the bottom left, then you can see that the circle expands from there and also our gradient, because at the bottom left it's more orange than at the bottom right. And let's also click on different positions. Yeah, then you can see this works very cool and very smoothly. Let me also quickly show you one more thing. In our animation definition here, where we define this in the curating scope, we can change this to 105, for example, and launch this again. You will see that the circle does not fill the grid item anymore because the target value is too low here. So always make sure that this target value is high enough to fill your grid item. But on the other hand, if you expand this or increase this to 500 and launch this again, then you can see that the gradient does not work that good anymore, because now the whole field is just orange, because the circle is very big and this is just a little part of the circle. So always be sure to choose a good target value here to make this work with the gradient, and so that it does not get too big. Alright, okay, this was it for this video. I hope you enjoyed it. And in case you want to see more about Jetpack Compose and Canvas, then check out my YouTube channel or leave a subscribe, because I will continue making such videos, sometimes on more basic stuff and sometimes more advanced stuff. So see us then.